Okay, we've reached the final unit of this course, single variable linear equation. You guys have come a long way. This is Glenn for Dawson, and here's what we're going to be learning in Unit 5. So basically what we're going to do in this chapter is we're going to just go over some complex problems and bring it all together. So let's get going. So let's start here. So what we have here is actually a fraction, right? A fraction is when you have a numerator over a denominator, okay? And this is equal to something, in this case 4, okay? So remember, to get rid of this fraction, we have to multiply by the denominator. In this case, that's 2. So we want to do that so we can split this up, right? So I'm going to multiply by 2 on both sides. Principle is the same. The principle is the same, even though the numerator, okay, is x plus 5 and not just x or not just 5, right? But remember, if you multiply by 2 on the left-hand side, we have to do the same thing on the right-hand side. So multiplying by 2 on the left-hand side cancels out the 2. So on the left-hand side, I'm left with just x plus 5. And on the right-hand side, I'm left with 4 times 2, which is 8. And of course, this now is a very easy problem for us. So all we did there was take a look at this, what used to look complicated to us, and say, not a problem, we've got this. Now I'm going to transpose this 5, take it over here, which means its sign is going to change. So I'm going to have x alone on the left-hand side, which is our goal. And I'm going to have 8, which was already there, minus 5. Hence, x is equal to 3. And so 3 then is our answer. Okay. All right, let's try another one. So what we have here is a little bit more complicated than what we just did, but the principle is the same. Before I multiply it through by 2, what I'm going to do is recognize that I have a constant here. See, this is a constant. I can get rid of this easily. I can transpose this. See, when I transpose this, this will become minus when it comes on this side. So if I take this over here, I'm going to be left with on the left-hand side simply 3 minus x divided by 2 is equal to 4 minus 5, which is minus 1. Okay, so on the right-hand side, I'll have 4 minus 5. I took the 5 over. Okay, so this really is what I get when I do 4 minus 5. Okay, now what I'm going to do now is I'm going to realize that I have a fraction here. And to get rid of the fraction, I know what I have to do. I'm going to multiply it by 2. Why did I choose 2? It's not always going to be 2, but I'm choosing 2 because that's the denominator, and that's going to cancel. Okay, so I'm going to be left with just 3 minus x here, but I've got to remember that both sides have to be multiplied by 2. So minus 1 times 2 is minus 2. Now I have minus x is equal to minus 2 minus 3. How did I get a minus 3? Because I'm going to transpose this constant, which on the left-hand side is positive 3. How do I know it's positive? Because it does not have a sign in front of it. Therefore, we take it as positive. So when I take it on the other side, it becomes negative. So I'm going to have minus x is equal to minus 5. And we're done, right? Not quite. Remember, we're looking for x is equal to something. We're not looking for negative x is equal to something. And what I also want you to remember is that when you have negative x, that's the same thing as negative 1x. So to get rid of this negative 1 in front of the x, I've got to divide both sides by negative 1. So that cancels out the negative here, because this is negative 1 here, remember. So I'm left with just x over here. And negative 5 divided by negative 1 is positive 5. Remember, these are like signs. See, negative divided by negative. Positive divided by positive. If it's like signs, it's positive is our answer. Okay, so our answer here is 5. So this problem that once looked complicated to us, now we're able to do it. Okay, so again, remember, we should be building our confidence at this point. Okay, we're good. We're good. All right, let's look at another one. Okay, so I have 2 multiplied by 3x minus 4 inside brackets. Okay, or we could say 2 quantity 3x minus 4. That's one way to say it, but let's stick with the brackets, okay? Is equal to 12. So what I want you to understand is that this is just a product here. This is just as if you had 2a is equal to 12, except a is 3x minus 4, okay? So there are 2 ways that we could work a problem like this. One is multiply the 2 times everything inside the brackets, okay? And we could do that, okay? So I'll go ahead and do it that way first, and then I'll show you another way, okay? So I have 2, 3x minus 4 is equal to 12. So 2 times 3x, so again, when there's a bracket situation, if we're multiplying by something on the outside, it has to be multiplied by everything inside the bracket. That's how we expand it out. So 2 times 3x is 6x. And 2 times minus 4 is minus 8. And this is equal to 12. And now I've got to get rid of this minus 8, so I'm going to transpose it, and it's going to become positive. So I'm going to have 6x is equal to 12 plus 8. So 6x is equal to 20. Now I have to divide both sides by 6. So these cancel, so I'm left with x is equal to 20 over 6. But they're both even numbers, so I can reduce this some more. And when I reduce this, I'm going to realize that x is equal to 10 over 3. Okay, so how did I reduce this? 2 into 20 is 10. And 2 into 6 is 3. Okay, so that's one way we could have done that. Another way is realize that I could divide both sides by 2. See, remember if I had like 2x is equal to 6, I would divide both sides by 2 because I want to get rid of this 2. Here, I could do the same thing. Now, we can always do that, but it's not always going to make sense because it's not always going to give us a nice and pretty number. 12 can be divided by 2 with no remainder. So that's going to give us a pretty number. So if I divide this by 2 and divide this by 2, this cancels. And by dividing the next side by 2, I'm doing the same thing on both sides. So if this cancels, I'm left with 3x minus 4 is equal to 6. Now, take this constant over here, it becomes positive, so I'm left with 3x is equal to 6 plus 4. So 3x then is equal to 10. And then I can divide both sides by 3 to get rid of this 3. And so then x is equal to 10 over 3. So you want to go with either of these where it's doable, but in cases where this isn't divisible by the number here, then let's just go this route. We'll just multiply everything out. Okay? All right, let's look at this one. Here's an example where if I divide 5 by 2, I'm just going to end up with 5 over 2. I'm not going to get a number. It's not going to make my problem easier. So I need to just multiply this out. So why don't you give this video a pause and try it. All right, so let's multiply everything out that's inside the bracket. This 2 is not multiplied by this 5, only what's inside the bracket. Okay, so then 2 times x is 2x, and 2 times 3 is 6, and this is equal to 5. Of course, I see a constant. I want to transpose that, and when I do, it will become negative 5 minus 6. And so I have 2x is equal to minus 1. 5 minus 6 is minus 1. All right, now I have a coefficient here, so I got to get rid of that. So I'm going to divide by 2 on both sides. So then x is equal to minus 1/2. And that's my answer. So again, these once thought of difficult or complex problems are not so bad. They're not so bad. Okay. Now, dealing with fractions and integers and stuff may be something that you learned at such an early stage that you may need some reminders. I want to remind you that you can follow us. Okay. Facebook, Instagram, but particularly on YouTube, I have a ton of videos, and I'm making videos every day to post to help people out physics and math. So if there's something that you'd like to see there, check to see if it's there. If it's not, leave a comment on one of the videos or contact me through one of these mediums, and I'll gladly make a video that will help you. All right, let's try this one. So again, if you could imagine when you started this course, if we had started here, many of you would have been like, yeah, this isn't the course for me. Or yeah, I don't think that I can learn this. I don't think I have the capacity. Yeah, you can, and we are. So what we have here, guys, is two fractions. And we got to get rid of these fractions. Now, if it was just 2 as a denominator for both of them, we would just multiply by 2. Or if it was just 3, that's the denominator, we'll just multiply by 3. The truth of the matter is you have to multiply now by the LCM. And I have a recent video on YouTube with the LCM. You could check that out. But just a quick reminder, the LCM is the least common multiple. Okay, so let me tell you what that is, and then I'll tell you why we're choosing that. So the LCM of 2 and 3 looks like this. This is the layman's way to look at it. Multiples of 2, 2, 4, 6, 8, 10, and so forth, right? So refresh your memory on what multiples are. Multiples of 3, I have 3, 6, 9, 12, etc. The least common multiple or the lowest common multiple. So we look for multiples that they have in common. So they have 6 in common. If you go on, you'll find that they have 12 in common. And then they'll have 18 and so forth, but the lowest or the least is 6. So in other words, 2 can go into 6 without a remainder. 3 can go into 6 without a remainder. So I'm going to choose to multiply by the LCM. And the reason I'm going to do that is because I'm not going to get a remainder, therefore I can cancel a fraction. What do I mean? Let's look at the first one. If I multiply 6 times x over 2, this cancels, this becomes 3, so I get 3x. That's not a fraction. That's not a fraction. Let's look at multiplying 6 times 2x over 3. 3 into 3 is 1, 3 into 6 is 2, 2 times 2x is 4x. That's not a fraction. So you see, with doing that, I get rid of the fraction, which is what I want to do to get started. The fraction alone is what has me thinking from the very get-go, ooh, this is complicated. So I want to get rid of that. And now we know how. So we're going to multiply by 6, and we know why. But if we do that on the left-hand side, we have to do it on the right-hand side. Furthermore, let's recall that whatever we're multiplying by has to be multiplied through every term on both sides. So 6 times x over 2, well, we already did it. 6 times x over 2 is 3x. Okay, let me repeat why. 2 into 2 is 1. 2 into 6 is 3. 3 times x is 3x. Plus 3 into 3 is 1. 3 into 6 is 2. 2 times 2x is 4x. Okay? It's 4x. But then we also have to multiply the right-hand side. We have to multiply the right-hand side. So 5 times 6 is 30. Now, remember our grouping. The very first chapter of this course. We can add x's and x's, apples and apples. So 3x and 4x gives us 7x. 7x is equal to 30. Okay. So now we have to divide by 7 to get rid of this 7. But if we do it on the left-hand side, we have to do it on the right-hand side. So when we do that, we'll be left with x on the left-hand side is equal to 30 over 7. That cannot be reduced because 7 cannot go into 30. Therefore, this is our answer. Okay. Very good, very good, very good. All right, so this is your final practice. Here are some problems that I need you to work. What I'm going to do is I'm going to give you the solution for them as well. So for number 1, what you should get is minus 1/2. And for number 2, what you should get is 7. For number 3, what you should get is 4. This is the value for x in these, okay? And for number 4, you might recognize this problem as the problem on the cover of the book for this course. When you started this course, you had to click on a book and it took you to the course. That's the problem. So you should be able to pat yourself on the back if you're able to solve this problem. This is just practice. And if you do, you're going to get minus 8 as your answer. All right. Good. Well, we've come to the end of the course. There is an assessment after this one. You know the deal. You have to get a 70% to pass it. The assessment, though, is a little different than the others because this assessment covers everything we've done since the start of this course. So you'll have a little bit more time for that one. But more important than getting our A's is always learning. If you've learned or benefited from this course and would like to see more like it, leave a comment. And most definitely share with a friend, family, or colleague. We have other courses on here, so you might want to view the courses section to see what's already there. If you have a topic, a subject that is giving you some issues, school, okay, or you just want to refresh your memory, let us know, and I'll be glad to create a course for you. If you just want to problem solve, I can put it on YouTube for you. All right. See you soon.